Let's solve another example that concerns conductivity. Before we move further, let's know that conductivity is the inverse of resistivity. So, if resistivity, rho, is the inverse of conductivity, then conductivity, sigma, will be equal to 1 all over rho. That is, if rho is equal to RA divided by L, that is our equation 3 from the beginning, that we have rho to be equal to R times A divided by length. Then sigma is the inverse of resistivity. That will be 1 divided by resistivity. So with this, we can now have that a question can be asked that a 30-meter conductor of cross-sectional area 2 millimeters squared has a resistance of 10 ohms. Calculate the conductivity of the metal. I repeat that a 30-meter conductor of cross-sectional area of 2 millimeters squared has a resistance of 10 ohms. Calculate the conductivity of the metal. Now, the data is or are length L is equal to 30 meter. So the conductor is 30 meter long, and a cross-sectional area, that is area A, equal to 2 millimeter squared, 2 mm. Remember that the first m is part of the unit or part of the value of this area. M is a value, that is milli, which is 10 to the power of minus 3. So area is still something as 2 times 10 to the power of minus 3 meter squared. Meter squared is the unit of measurement for area and has a resistance 10 ohms. So resistance R equal to 10 ohms. Calculate the conductivity of the metal. So find conductivity, that is sigma, which is equal to question mark, that is unknown. But remember that conductivity is the inverse of resistivity, and resistivity is R times A divided by L. So therefore, our conductivity will be equal to 1 all over R times A divided by L. That is, I repeat, if resistivity, which is rho, is equal to R times A divided by L, and if conductivity is the inverse of resistivity, which is 1 divided by rho, then conductivity will be equal to 1 divided by R times A divided by L, since RA divided by L is resistivity. So with this, we can make we can solve for conductivity by first. This is the same thing as L divided by R times A. Mathematically, if you have 1 all over R times A divided by 1 all over L, if you manipulate that, you will arrive at L divided by R times A. That is the inverse of this, to bring this up and to take 1 down. So this is the formula that we'll be using. That is, conductivity, sigma, is equal to the length of the material divided by the resistance of the material multiplied by the cross-sectional area of the material. Now, with this formula, we can now impute our variables that we have here, where conductivity will be equal to 30 divided by the resistance is 10 ohms multiplied by area is 2 times 10 raised to the power of negative 3. Remember to always put this like this in a bracket so that we will have a correct answer. So, conductivity will be equal to 30 divided by 10 times 10 raised to the power of 10 times 2 times 10 raised to the power of negative 3 will give us 0.02. So therefore, conductivity will be equal to 30 divided by 0.02, which will be 1,500 ohm per meter. The unit for measurement for conductivity is either Siemens or ohm per meter. So, we have conductivity to be 1,500 ohm per meter, or conductivity is equal to 1.5 times 10 to the power of plus 3 ohm per meter. So this is the final answer to the question that says a 30-meter conductor of cross-sectional area 2 millimeters squared has a resistance of 10 ohms to calculate for the conductivity. Thank you.